Introducing Optilogic's Global Supply Chain Strategy Database Template, the ultimate tool for answering your global network strategy questions. Join us as we take a deep dive into this powerful database with Optilogic's Senior Director of Product Management, Jim Wilson. In this video, Jim will be providing insightful context around the database and highlighting key features that make it an invaluable asset to any supply chain professional. The database structure includes raw materials suppliers from Asia and Europe, production plants in the USA and Mexico, and outbound distribution to over 1,000 customers based in the United States. With this template, you'll be able to answer critical questions such as, what is our baseline as-is network? What would happen if we increased production volume in Mexico? What if we closed the Detroit distribution center? What if demand increased by 10%? You'll also be able to analyze the financial trade-offs between production cost, transportation cost, and fixed operating cost. Additionally, you'll be able to evaluate the trade-offs between financials, service level, and risk. Whether you're an experienced supply chain professional or just getting started, Optilogic's Global Supply Chain Strategy Database Template is the perfect solution for taking your global network strategy to the next level. So sit back, relax, and join us as we explore the endless possibilities of this incredible database.
So firstly, let's start with the product groups. We extended the model so that we're bringing in raw materials and converting them into finished products. So the finished products are spacesuits, consumables, and rockets. And then we also have multiple raw material 1 to 9, that are going to come in from China and Europe, and then they're going to be converted at the factories in El Baggio and Princeton, Indiana. Next thing to call out are the facilities. So we have different types of facilities in this model. We've got distribution centres, which ultimately are serving the customer, and they're receiving finished goods from the factories, and we have 7 of those. We then have the factories, one in Princeton, Indiana, and one in El Baggio in Mexico. And this is where the production's happening. We're taking the raw materials and converting them into finished products. But we also need to bring those raw materials in from both Europe and China. So we have facilities that represent ports, and we have exit ports from those continents in Shanghai in China, and Rotterdam in Europe. And then those products are coming in by boat to Charleston in North America and Altamira in Mexico. And then finally, we also have suppliers. So this is where the raw materials are coming in. We have suppliers in Europe. We have quite a few of them. We can see Paris, Madrid, Barcelona. And then we also have suppliers in Chengdu, Beijing, Guangzhou, across China. So suppliers in both of those different regions. So it's often easier to visualize this on a map, and this would be a good opportunity to jump across. And we've got our pre-configured supply chain map here. So I can just start selecting entities. And here we have our suppliers. We can see all of the suppliers across Europe and all of the suppliers across China. We also have ports. So if I put those ports on, we can see that we've got a port here in Rotterdam to be able to move things on a boat out of Europe. We've also got one here let's jump across to Shanghai in China. And then in the US, we've got Charleston on the eastern seaboard, and we've got Altamira port in Mexico. So we can also bring those goods in through ports, those raw materials, and get them to the factories. Once those raw materials have reached the market where we want to convert them, then what we can do is we can bring them to the factories. We have 2 factories here in North America, one in Indiana, in Princeton, Indiana, and one down here in El Baggio. And then once those finished goods have been produced, we can move them out to the 7 distribution centres, and then ultimately on to each of our customers in the US. So now let's take a look at some of the detail that's happening at the factories. We can also look at the suppliers as well. So we go back to our data. Then we've populated the suppliers capabilities table. And what this is really doing is it's showing which raw material can come from each supplier. Now at the moment I've just said that one raw material is available at a specific supplier. Of course we could start opening this up later so that there's multiple supply options and we could make the supply decisions as well. But at the moment this model is just taking a raw material from a specific supplier. And then if we go into our factories, both the factories we have production policies. So we can see here that the consumables product can be made at both factories. That can be made at El Baggio and Princeton. Rockets only available at El Baggio and spacesuits only available at Princeton. But we can also see here that these are using bill of materials, and this is describing how those raw materials get converted. So if we move to the bill of materials table, then what we can see here is if we take consumables, for example, consumables are made up of 3 raw materials, raw material 1, 2 and 3, and they have different quantities of those raw materials that they can consume. So in terms of other data that we've got in the model, it's a single period model, and we'll call that out. We've also got transportation policies. So transportation policies using groups. So for example, here we can see we can go from the Princeton factory, and that factory can service all the distribution centres. That's using a group. If we come down here, for example, we can see that we have a group called EMEA suppliers. So all the suppliers in Europe are in a group, and they're all able to move to the Rotterdam port. And then of course we have a transport lane that moves goods from Rotterdam to Charleston. So we have all of our transportation policies. We of course have customer demand, that's all loaded in there. We also have a flow constraint for the baseline, and this is really important. This is basically limiting the amount that flows from the El Baggio factory into all of the distribution centres, and that's limiting it to a maximum of 3.5 million eaches or units. And then finally we've got our groups table populated as we're using groups. So now let's talk about our scenario. So we obviously have the baseline. This is going to be run and represent the current network. So no items associated with it. That flow constraint of 3.5 million units between El Baggio and the DCs will be respected. Then the first thing we'll do is we'll test a scenario where we remove that flow constraint. So what we're saying here is, what if we invest in additional transportation capacity so we can move a lot more product from Mexico up into the distribution centres? We know that we can make 2 products there. We can also make consumables, and the cost of manufacture, the cost of production down in Mexico is much cheaper than North America. So this is going to be an important one to check out. Then additionally, we know that the lease is coming up on the Detroit distribution centre. It's got a few months to run, and we have the option to get out of that DC if we want to, contractually. So we're going to start layering these up. We're going to say, well, what does the world look like if we remove those flow constraints, and then we also don't have the Detroit distribution centre? We're asking the question there whether or not we should renew the contract. And then finally, again, building on top of that, we have the ability to go and say, well, what if demand increases? And we're actually expecting some growth in demand to the tune of 10%. So our final scenario is looking at not having any constraints for moving things in from El Baggio, not renewing the contract with the Detroit DC, and then also having that increase in demand. So once we've run those scenarios, we're able to go back and see the raw output and the output tables. So for example, we can jump into network optimization summary, and for each of those scenarios we can start to see headline figures around the total supply chain cost, how much demand was serviced, transport, production costs, etc. And then we have all the detail underneath each of those in each of those tables in terms of flows and how the demand was allocated, how production's working, and the bill of materials that were used and converted to make finished product. But this is really where, so we can look at the information at this level, but this is really where maps and analytics come to the fore. So we can see in the baseline that our production costs are about 46 million, transportation costs are about 67 million. And then we also have the fixed operating costs associated with the distribution centres. And when we remove that flow constraint, so when we can now move an unlimited amount out of El Baggio, we can see that the production cost actually comes down to about just over 33 million. So there's a 12 million reduction there in terms of production costs, and that's really because it's much cheaper to make product in Mexico. But we also see that transportation increases by about 10 million. So net we have about a 2.5 million saving, and that transport cost increases because we need to move more product further out of Mexico into those distribution centres. And then as we move forward, we can see that the production cost stays the same in scenario 3. Everything's still being produced in the same place. But our transportation costs go up marginally again. They go up by about $1 million. And that's because we've now decided to close the Detroit DC and get out of that contract. And that's given us a marginal transport cost increase, given the fact that we have to service Detroit's distribution area from Chicago and Philadelphia. But we also remove the fixed cost associated with Detroit. So again, the net effect is we actually have a cost saving. And then finally, we can see that when we increase demand by 10% across all those scenarios, then we see an increase in both the cost of production, because we're having to produce more product, and also an increased cost in transportation, because we're having to transport more product as well. So, that's the story behind each of the scenarios. So now let's go and tell that story on the map. So if we go to the map, we can, again, we'll start putting on our suppliers, and let's put on our ports, but also let's put in our inbound flows. So these are flows coming in from the suppliers into the ports. We can see here these are raw material products being moved in from the suppliers in Europe, and over here we have the raw material products being moved into Shanghai, the port that's going to get moved to move the goods to the US in China, and up here they're moving it into Rotterdam. So what we can then do is we can then put the port-to-port flows on, and what that will do is that will show product flowing from those ports in Rotterdam and Shanghai into Charleston and into Altamira in Mexico. And then if we look at our factories, we can see that for Princeton and El Baggio, we're able to move goods from those ports into those two facilities. And then if we lay on our distribution centres, we can see the flows to each of the customers. We'll just take those off for a moment. We can see the flows from each of the production sites going in, the factories going into those distribution centres. And then we can also start to see the customers and how those customers are serviced. Now obviously the map starts to get busy fast, and this is where we can start applying filters. So I'm just going to take off some of the detail in terms of the customers and the allocations. And at the map level we can do two things. We can select which scenarios we want to look at. So at the moment we're looking at baseline, but what we can also do is we can go in and we can put product group filters. So I'm going to select consumables. We can actually select multiple products here if we want to. And then what we'll see is that is now showing just the flows between the production sites, the factories that are making the finished product, and the distribution centres. And consumables are flowing out of mainly out of Princeton, Indiana, because that's where the capacity is. And there's a small amount of overflow capacity in Mexico, which it's using to make a small amount of consumables. But if we change scenario to one where we've removed that capacity from Mexico, but what we'll see here is those flows then change, and we now have the capacity to make all of the consumables products at Mexico, and that's flowing all of the total finished goods demand for consumables into those DCs. And that's where we get the reduction in production costs, because it's much cheaper to make things in Mexico, but we can visually see that we're now transporting those goods much further, hence the transportation cost increases. So now let's go and look at the differences in customer allocations where we close the Detroit DC. So we can go back to the baseline, we take off that, switch back to that scenario. I'm going to remove consumables, and I'm also going to put on my DC to customer flows. And what we can see here is that that's the distribution boundaries between Detroit, Chicago and Philadelphia. I'll just take a little bit more information off there as well. Let's take the port-to-port flows so you see the map a bit more clearly. So we can see the distribution boundary that's been serviced by Detroit. And of course, if we go and we now switch to scenario 3, where it's Detroit's been removed, it's been closed, and we update that, then we can see that that distribution boundary has been picked up by both Chicago and Philadelphia. And then ultimately we can see that we've lost the fixed operating cost of removing Detroit, but this is why our transportation cost has increased, because we're actually doing more miles now to service those customers. So this is just an example of how we can start to use the analytics and the maps to really tell the story, and hopefully it's helped with some context to the story behind this model.